Statistic 1, AS A level, paper 62, May June 2018. In a group of students, 3/4 are male. The proportion of male students who like their curry hot is 3/5, and the proportion of female students who like their curry hot is 4/5. One student is chosen at random. I find the probability that the student chosen is either female or likes their curry hot, or is both female and likes their curry hot. We use the trie diagram to draw the proportion of each part. Thus proportion of male, that is 3/4, thus female is 1/4, and then proportion of male students who like their curry hot is 3/5, thus hot is 3/5, thus not hot is 2/5, and the females who like the curry hot is 4/5, thus likes the not hot is 1/5. Thus the question is find the probability that the student chosen is either female or likes their curry hot, or is both female and likes their curry hot. Thus actually that is these females with hot and females with not hot, or males with hot. That is the question in this part. Thus that is the question is probability of those females with hot and females with not hot. That is just here, that is enough. Those probability of female or male hot, yeah, those, or probability of males intersect hot. Thus that is probability of female plus probability of male intersect hot, that is 1/4 plus 3/4 times 3/5. Thus 1/4 plus 9/20, thus that is 14/20, or that is 7/10. The answer will be the same with this 3/4 times 3/5 plus 1/4 times 4/5 plus 1/4 times 1/5. That is the answers will the same. That is 7, also 7/10. II, showing your working, determine whether the event the student chosen is male and the student chosen like their curry hot are independent. Thus first we have to find the probability of male, that is you can see clearly in the trie diagram. Probability of male, that is 3/4, and then probability of a student chosen likes their curry hot, that is 3/4 times 3/5 plus that is from male, and then from female 1/4 times 4/5, that is 13/20, and then thus probability of male times probability of student chosen likes curry hot, that is 3/4 times 13/20, that is 39/80. Now the probability of male intersect hot, that is 3/4 times 3/5, that is 0.45. Thus from this calculation you see that probability of male times probability hot unequals to probability of males intersect hot. Thus the events are not. Question number 3, the volume of soup in super soup carton has a normal distribution with mean mu milliliters and standard deviation 9 milliliters. Tests have shown that 10% of cartons contains less than 440 milliliters of soup. Find the value of mu. Yeah, so find the value of mean. Now, here I sketch the standard normal distribution. Yeah, that is a standard normal distribution. If the area below that one from here until that the 0.9, you can use your table or calculator. You can show in your table that Z or calculator Z here that is 1.282. Now, by symmetric property, if I choose here and here is 0.1, here is 0.9, thus the Z here by Z here is minus 1.282. That is 282. This is also 282. Now, thus the test shows that 10% of the carton contains less than 440 milliliters soap. Thus means 0.1 is less than x 440. Now, first we use the standardization equation. Standardization equation is z equals x minus mu per sigma. Thus x minus mean per standard deviation. Thus here we will standardize x. Thus x is 440. 440 minus mu per standard deviation, that is given 9, is equals minus 1.282. Thus from here we can calculate that mu is 452. 3 significant figures. II. A food retailer orders 150 super soup cartons. Calculate the number of these cartons for which you would expect the volume of soup to be more than 1.8 standard deviation above the mean. Now, you can sketch the standard normal distribution, that is this one, standard normal distribution. And yeah, here is mu, mean, and first you have to find x, which is 1.8 standard deviation above the mean. This is x, that is mean plus 1.8 times standard deviation. 1.8 times 9, thus actually x here that is 467.738. Now, thus the equation is first you have to find the probability when x greater than 467.738. Thus we standardize this x, that is pz greater than 467.738 minus mu. Yeah, we use mu with 3 decimal places. This 451.538 per 9, and then that is pz greater than 1.8. This is 1.8, and from the table or calculator we obtained that the probability is that is 0.03593. Thus the number of cartons, that is the probability, times 150, that is 5.3895, thus approximately 5 cartons. Question number 4. Mrs. Ruppel chose 3 animals at random from 5 dogs and 2 cats. The random variable x is the number of cats chosen. I draw up the probability distribution table for x. Now here is the random variable x, that is the number of cats chosen. Thus there are 2 cats. Thus the random variable 0, 1, 2 means if x is 0 means no cat has chosen those the animals all from the dogs, those 3 dogs, and then if x is 1 means cats 1 and dogs is 2, and if 2 cats 1 dogs to find the probability, we use the combination here. Those probability when x 0 means no cats, that is 2 combination 0, the 2 is from 2 cats, times with 3 from the 5 dogs, those 5 combination 3 per 7 combination 3. Yeah, those 7 animals, we choose 3 from the 7 animals, that is 7 combination 3. Those probability when x 0 is, that is 2 per 7th, and then when x is 1 means 1 cats from 2, we choose 1 cats from 2 cats, those 2 combination 1 times 2 dogs, 5 combination 2 per 7 combination 3, that is 4 over 5, and when x is 2, probability of when x is 2, that is 2 cats means 2 combination 2 and 1 dogs times 5 combination 1 per 7 combination 3, or that is 1 per 7. Thus the corresponding probability of when x is 0, that is 2 per 7, x1 the probability 4 over 7, and then when x is 2 the probability is 1 per 7. Thus this is the probability distribution for x. Now II, you are given that expectation of x, that is 6 per 7. Find the value of variance x. Now the formula for variance, that is variance x equals to expectation of x squared minus expectation x squared. Now expectation of x squared, that is 0 squared times 2 over 7 plus 1 squared times 4 over 7 times 2 squared times 1 over 7 minus expectation of x in squared, that is minus 6 over 7 squared, and then that is 8 over 7 minus 6 over 7 squared, that is 20 per 49. Thus this is the variance of x. Question number 5. The length 30 minutes of 242 phone calls made by a family over a period of 1 week are summarized in the frequency table below. Thus this is the frequency tables. The length of phone calls t from 0 until 1 minute there are 14 calls, and etc. For example, t from 10 to 30 there are 40 calls. And then here there is a unknown frequency for time interval from 5 to 10 here, a. No, the question I, find the value of a. No, those total frequency, that is 242, that is given here. Those sigma frequency is 242, means 14 plus 46 plus 102 plus a plus 40 equals 242. Thus from here we obtain a is 40. Thus that is the value of a. II, calculate an estimate of the mean length of these phone calls. Now that is the frequency table. Thus that is in the form of grouped frequency distribution, and the time is in given in the interval. Thus we use the mid value of each interval. That is why here we will obtain the estimation, because time is given in the form of interval. Thus we use the mid value of that time interval to represent the time in its class or in its interval. Thus mean equals sigma mid class value times frequency per sigma frequency. Thus the first class, that is time from 0 to 1, the mid value is 0.5 times the frequency, And the second class, time from 1 to 2, that is mid value is 1.5 times 46. And then the third class, the mid value is 3.5 times frequency 102. And the fourth class, mid value 7.5 times the frequency 40. And then the last class, that is the mid value is 10 plus 30 divided by 2, that is 20 times frequency 40 divided by the sigma frequency 242. And then that is the mean is 681 per 242, or that is 6.33 to 3 significant figures. Now, triple I, on the grid, draw a histogram to illustrate the data in the table. Yeah, those from the table we see that the class has unequal width. Thus, that is why we will use to draw the histogram, we will use as the height of the bar, that is the frequency density. Yeah, thus frequency density, that is frequency per width of class. Yeah, because its times interval or times intervals are different width. That is why we use the frequency density as a height for the histogram here. Thus first we calculate the frequency density of its class. The first class, the frequency is 14, and the width of the class, that is 1 minus 0, that is 1, that is the 14. And the second class, frequency 46 divided by width of class 1, that is 46. And the third class, that is frequency 102, and the width of class, that is 3 and 34, etc. And the last class, the frequency is 40, and the width of the class, that is 20. Those the frequency density is 2. Now this is the histogram. Those in the vertical axis we use the frequency density. In the horizontal axis, that is length phone calls in minutes. Thus the first bar, that is from time interval from 0 to 1, and the height, that is the frequency density, is 14. And the second class, that is time from 1 until 2, and the frequency density is 46, etc. And then the last class, that is time from 10 to 30 minutes, and then frequency density is 2. Thus this is the histogram illustrate the data in the tables. Thank you.